Let's say you're floating in the deepest part of space, surrounded by absolutely nothing. No stars, no planets, no light, just emptiness, or so you think. But suddenly, without warning, the fabric of space itself starts to shake, not vibrate, shake, like a massive earthquake, except there's no ground. The invisible skeleton holding the entire universe together is cracking apart, sending shockwaves that travel faster than light itself across billions of miles. This isn't some Hollywood disaster movie. This is real. This is happening right now, somewhere in our universe, and we call it a dark matter quake. Hey everyone, what you just imagined is one of the most violent, mind-bending events in the cosmos. I'd like you to take a brief moment to join a community that values curiosity over conformity. Hit that subscribe button and let's explore the extraordinary together so you'll never miss a video. Today, we're diving deep into the most extreme, reality-breaking phenomena ever discovered in space. We're talking about explosions that make our sun look like a birthday candle. Black holes so massive they could swallow our entire solar system for breakfast. And yes, those dark matter quakes that literally break the universe's backbone. Buckle up. The universe is about to get a whole lot weirder than you thought. The invisible universe. Okay, let's start with something that's going to blow your mind. Ready? Everything you can see in the night sky, every star, every galaxy, every beautiful nebula photo from the Hubble telescope, all of that represents less than 15% of what's actually out there. Imagine you're at a concert, but you can only hear 15% of the music. The other 85% completely silent to your ears, but it's there. And it's what's actually driving the entire symphony. That's our universe. The majority of it is made of something called dark matter, and it's completely invisible. Can't see it, can't touch it, can't Instagram it. But here's the thing. This invisible stuff is literally holding everything together. Think of dark matter like the universe's skeleton, just like you can't see the bones inside your body. But they're what keeps you from being a puddle on the floor. Dark matter creates this massive cosmic framework that galaxies hang on to, like Christmas ornaments on a tree. But here's where it gets insane. This skeleton isn't solid. It's more like a giant spider web made of invisible rivers and streams stretching across the entire universe. Scientists call it the cosmic web, and it's probably the most beautiful thing you'll never see. Our Milky Way? It's just sitting in one tiny corner of this web, surrounded by dark matter that weighs 5 times more than all our stars combined. And for the longest time, we thought this web was pretty stable. We were wrong, dead wrong. In 2019, scientists noticed something weird. Stars in our galaxy were moving like they'd been hit by a massive invisible truck. Something enormous had crashed through our cosmic neighborhood, leaving behind what looked like stellar tire tracks. They called it the Gaia sausage, which sounds way less terrifying than it actually is, because what it meant was that the dark matter web around us isn't nearly as stable as we thought, and that was just the beginning of the nightmare. When the universe breaks. Meet Dr. Elena Rodriguez. She's the kind of scientist who stares at radio telescope data all day and somehow finds it exciting. Lucky for us, because what she discovered is absolutely terrifying. She was looking at signals from some of the most powerful radio telescopes on Earth when she saw something that should have been impossible. Multiple galaxy clusters. We're talking structures containing thousands of galaxies each. We're all freaking out at exactly the same time. Here's the problem. These clusters were so far apart that light hadn't even had time to travel between them. It's like having earthquakes simultaneously hit Japan and California. Except Japan and California are separated by billions of years of travel time. At first, I thought our equipment was broken, Dr. Rodriguez said. But the more we looked, the more we realized we weren't seeing broken equipment. We were seeing a broken universe. What she had stumbled onto were the first confirmed dark matter quakes. Remember that cosmic web I mentioned? Well, imagine if all the cables on the Golden Gate Bridge were under massive tension, and then one of them just snapped. The other cables would start failing in a chain reaction, right? Now scale that up to cosmic proportions, where the cables are made of invisible matter and stretch across distances that would take light billions of years to cross. The biggest dark matter quake ever recorded happened in something called the Boötes supervoid. Don't let the fancy name fool you. This thing is basically a cosmic dead zone that's 330 million light-years across. To put that in perspective, if our galaxy was the size of a coin, this void would be bigger than Texas. And inside this void, something unimaginable happened. A dark matter structure just collapsed. The energy release, more powerful than 1 billion supernovas exploding at once. But here's the really weird part. Unlike a supernova that lights up the sky, dark matter quakes release their energy as pure gravitational waves, invisible ripples in space itself that we're only just learning to detect. Remember those gravitational wave detectors that won the Nobel Prize for finding black hole collisions? Yeah, they started picking up these weird signals in 2020. At first, scientists thought it was just noise. Turns out, it was the universe screaming. But if you think dark matter quakes are extreme, wait until you hear about the most violent explosions in the cosmos. Cosmic explosions that make nukes look cute. December 27th, 2004. Christmas was over. Everyone's dealing with post-holiday blues. And then the universe decided to remind us just how small and fragile we really are. An explosion 50 light-years away, that's halfway across our galaxy, was so violent that it temporarily blinded space telescopes and actually messed with Earth's atmosphere. If this explosion had happened just 10 light-years from us, you wouldn't be watching this video, because complex life on Earth would be extinct. This was a gamma-ray burst, and they are absolutely the most ridiculously overpowered events in the known universe. Here's how insane these things are. A single gamma-ray burst can release more energy in 10 seconds than our sun will produce in its entire 10 billion year lifetime. Let me say that again. 10 seconds versus 10 billion years. But that explosion in 2004, that was nothing compared to what we detected in 2022. GRB 221,009A was an explosion so bright that it happened 2.4 billion light-years away and was still visible to the naked eye from Earth. For a brief moment, this explosion outshone every single star in our night sky except the sun. Think about that. An explosion that happened when Earth was just forming single-celled life was so powerful that it could still light up our sky like a new star. These explosions happen when the most massive stars in the universe finally run out of fuel and collapse. But they don't just collapse. They collapse and then fire jets of material at 99.9% the speed of light. We're talking about cosmic blowtorches that can sterilize entire solar systems. Dr. Michael Chen studies these things for a living, and even he sounds scared when he talks about them. A single gamma-ray burst releases more energy than all the stars in the observable universe will produce over the next trillion years. But as absolutely insane as gamma-ray bursts are, they're still just the death throes of individual stars. What happens when entire black holes go to war with each other is on a completely different level. When black holes fight, in the center of almost every galaxy, there's a monster. A supermassive black hole that's millions or billions of times heavier than our sun, just sitting there like a cosmic vacuum cleaner, occasionally snacking on nearby stars. Most of the time, these things are pretty quiet. But when galaxies crash into each other, and yes, galaxies crash into each other all the time, their central black holes get forced into the ultimate deathmatch. Picture two black holes, each weighing as much as 1 billion suns, spiraling toward each other for millions of years. They're moving so fast and generating so much gravitational energy that they literally warp space and time around them. When they finally collide, the explosion is so violent that it creates gravitational waves powerful enough to kick the resulting black hole clean out of its galaxy. These rogue black holes have been spotted racing through space at thousands of miles per second, carrying the mass of 100 million suns with them. Imagine a black hole the size of our solar system, just flying through space like a cosmic cannonball. But even scarier than black hole collisions are black holes that are actively feeding. Meet TON 618, the brightest object in the known universe. This thing is powered by a black hole that weighs 66 billion times more than our sun. It's so bright it outshines 140 trillion stars, and it's hungry enough to eat our entire solar system every few days. When matter falls into one of these monsters, it heats up to billions of degrees and gets shot out in jets that stretch for hundreds of thousands of light years. These jets move at nearly the speed of light and can punch through entire galaxy clusters like cosmic drill bits. The most extreme feeding frenzy ever recorded happened in a galaxy with an unpronounceable name that I'm not even going to try to say. The central black hole basically had cosmic indigestion and started ejecting material so violently that it cleared out everything within thousands of light years. The energy release was like our sun, exploding every single second for 1,000,000 years straight. But here's the thing about all these cosmic disasters. They all involve normal matter and energy. Dark matter quakes are something completely different. They're failures in the underlying structure of reality itself. The discovery that changed everything. Sometimes the biggest discoveries happen by accident, and sometimes they happen because you let a computer program loose on data that would take humans centuries to analyze. That's exactly what happened to Dr. Yuki Tanaka in Tokyo. She was using artificial intelligence to analyze the positions and shapes of hundreds of millions of galaxies, looking for tiny distortions caused by gravity bending light. It's incredibly detailed work that basically maps the invisible matter in the universe. But the AI kept finding things that didn't make sense. The machine kept flagging regions where gravity was acting weird. Dr. Tanaka explained. At first, we thought it was finding errors in our models. Then we realized it was finding errors in reality. What the AI had discovered were scars. Gravitational scars left behind by dark matter quakes, or NTED. Regions where the cosmic web had catastrophically failed, leaving behind twisted space that was still affecting galaxies hundreds of millions of years later. The first confirmed dark matter quake, DMQ-1, had happened 50 million years ago in the constellation Perseus, but its effects were still there, still warping space, still influencing how galaxies moved through that region. But here's where dark matter quakes get truly bizarre. Unlike earthquakes on our planet, which spread out through seismic waves at a few miles per second, dark matter quakes can trigger simultaneous failures across vast distances through something called quantum entanglement. It's like having a house of cards, where pulling out one card can cause cards on the other side of the room to fall at exactly the same moment. Dr. James Morrison from Oxford University tries to explain it. When a large dark matter structure collapses, it creates a phase transition that propagates instantly through quantum connections in the field. We're talking about faster than light effects, not for information, but for structural changes. In other words, dark matter quakes don't just break the cosmic web locally. They can trigger cascading failures across distances so vast that light hasn't had time to travel between them since the universe began. And then came the discovery that made everyone realize we might be living in a fundamentally unstable universe. The Great Cascade. March 15th, 2023. Mark that date, because it's the day we discovered that our entire cosmic neighborhood is basically held together with cosmic duct tape. Gravitational wave detectors around the world started going absolutely crazy. Not just one or two signals, hundreds of them, all happening simultaneously across our local group of galaxy clusters. The Laniakea supercluster, our cosmic address that includes over 100 zero galaxies, including our own Milky Way, was experiencing what can only be described as a dark matter earthquake swarm. Dr. Lisa Chen led the international team that monitored the event. Our detectors were triggering constantly. We had galaxy surveys showing unexplained movements across thousands of objects. For a moment, we genuinely wondered if we were witnessing the beginning of a universe-wide collapse. The Great Cascade started with one massive dark matter quake in the Virgo cluster, 65 million light-years away. Within hours, it had triggered secondary quakes in the Coma cluster, the Perseus cluster, and dozens of smaller galaxy groups. It was like watching dominoes fall, except each domino was a structure containing billions of stars, and they were falling faster than light could travel between them. For 3 weeks, our cosmic neighborhood was in chaos. Over 200 individual dark matter quakes were detected, ranging from small events affecting single galaxy groups to massive failures that reshaped the cosmic web across hundreds of millions of light-years. The total energy release? If we could somehow convert all that gravitational energy into visible light, the Great Cascade would have briefly outshone every star in the observable universe combined. But here's what really kept scientists awake at night. Computer simulations suggested that our supercluster had been building up stress for billions of years. The Great Cascade wasn't a random disaster. It was a pressure release valve, nature's way of preventing an even bigger catastrophe. As Dr. Rodriguez put it, we're living inside a structure that's fundamentally unstable. It's like living in a house built on an active volcano, except the volcano is made of invisible matter and could erupt across the entire observable universe. The question that haunts cosmologists is simple. What happens when the next cascade isn't a controlled release? But before we get to that nightmare scenario, let's talk about the smaller-scale cosmic disasters that happen closer to home. When stars have nervous breakdowns. You think dark matter quakes are extreme? Let me tell you about magnetars, the universe's answer to the question, what if we made something that could kill you just by existing near it? A magnetar is what happens when a massive star collapses into a neutron star, but then cranks up the magnetic field to absolutely ridiculous levels. We're talking about magnetic fields 1 trillion times stronger than Earth's. How strong is that? Strong enough that if a magnetar was located where the moon is, it would erase every credit card, hard drive, and cell phone on Earth. If it was 600 miles away, it would literally tear apart your atoms. These things are so dense that a teaspoon of magnetar material would weigh as much as Mount Everest. And their crust, yeah, they have crusts made of crystallized neutrons, is under so much stress that when it shifts by just a few millimeters, it releases more energy than our entire civilization has ever produced. In 1998, a magnetar called SGR 1900-14 had what can only be described as a stellar temper tantrum. The starquake released energy equivalent to 1 million hydrogen bombs exploding every second for an entire year. But magnetars aren't the only stars having cosmic breakdowns. There are Wolf-Rayet stars out there that are so unstable they're literally blowing themselves apart. These stellar monsters lose mass equivalent to our entire Earth every single year through stellar winds moving at thousands of miles per second. And when they finally explode, we call those hypernovae, and they make regular supernovas look like firecrackers. Hypernovae are so violent they can carve tunnels through space itself, creating jets of material that remain active for weeks and can trigger mass extinction events on planets hundreds of light years away. But even these stellar disasters follow the normal rules of physics. The really scary stuff happens when the fundamental building blocks of the universe start to break down. The universe's expiration date. Here's something that will keep you up at night. The universe might have an expiration date. Everything we know about physics suggests that the Higgs field, the thing that gives particles their mass, is in what scientists call a metastable state. It's stable for now, but it could potentially collapse to a lower energy state. If that happened, it would create a bubble of completely different physics expanding outward at the speed of light, destroying everything it touches by literally changing the rules of reality. But here's something even scarier. Dark matter might be subject to the same kind of instability. Dr. Tanaka's latest research is genuinely terrifying. The frequency of dark matter quakes has increased by 300% over the past decade. This could be natural variation, or it could mean we're approaching a critical threshold where the entire dark matter field becomes unstable. Imagine if the invisible skeleton holding the universe together just started dissolving. Not all at once, but in cascade failures that spread faster than light, turning the cosmic web into cosmic dust. Entire galaxy clusters would lose their gravitational anchor and fly apart. Stars would be flung into the void. The carefully balanced dance of cosmic structures that took 13.8 billion years to create would unravel in a matter of centuries. But before you start building a bunker, there's some good news. The same forces that create these extreme events also drive the creation of new structures. Dark matter quakes, while devastating to existing cosmic architecture, actually clear space for new galaxy formation. Recent observations show dark matter deserts, regions cleared out by major quakes, beginning to refill with new streams of invisible matter. The cosmic web is more resilient than we thought. And who knows, maybe our growing understanding of these extreme events will lead to technologies we can't even imagine yet. If we could learn to predict or even influence dark matter quakes, we might eventually be able to engineer the large-scale structure of the universe itself. Now that would be something. So here we are, at the end of our journey through the most extreme, mind-bending, reality-breaking events in the cosmos. From stellar explosions that outshine entire galaxies to dark matter quakes that literally tear apart the fabric of space itself. What have we learned? Well, for starters, we live in a universe that's way more violent and unstable than most people realize. The ground beneath our feet, metaphorically speaking, is made of invisible matter that can shift without warning across billions of light years. But here's the amazing part. Despite all this cosmic chaos, here we are. Stable planets orbiting stable stars in a relatively stable galaxy, in a universe that's trying its best to tear itself apart. We are literally islands of calm in an ocean of cosmic violence. And that makes our existence not just unlikely, but almost miraculous. Every time we discover a new type of extreme event, whether it's a gamma-ray burst that can sterilize entire star systems, or a dark matter quake that reshapes the cosmic web, we're not just learning about distant disasters. We're learning about the fundamental forces that govern our cosmic home. And we're just getting started. Right now, as you're watching this video, telescopes around the world are detecting new signals, new patterns, new types of extreme events that we've never seen before. The universe is constantly writing new chapters in the story of cosmic violence, and we're finally learning to read them. So the next time you look up at the night sky, remember this: those peaceful-looking stars are sitting on top of an invisible web of dark matter that occasionally has catastrophic failures. That beautiful Milky Way stretching across the sky is surrounded by a halo of invisible matter that outweighs all our visible stars by 5 to 1. You're not just looking at a few thousand nearby stars. You're looking at the visible edge of a vast, dynamic structure that extends across the entire observable universe. A structure that's constantly evolving, occasionally breaking apart, and always rebuilding itself in new and unexpected ways. We live in the most extreme universe imaginable. And somehow, against all odds, we're here to witness it. The cosmos is stranger, more violent, and more beautiful than we ever dared to imagine. And tomorrow? Tomorrow our instruments will detect something new, something that will once again expand our understanding of just how extreme reality can get. Until next time, keep looking up. The universe is full of surprises. And trust me, you don't want to miss what happens next.